One sample hypothesis test. This is a data problem. A professor claims that the average final exam score in his differential calculus class is 90%. From the past study, the standard deviation is known to be 10%. A survey of 10 scores in percentages are randomly selected from the most recent semester. The data is shown in the following. The significance level is 1% in this study. So you have 10 data, right? And then 1% alpha. Question is, do you want to conclude that students have shown improvement in the most recent semester? Is there enough information to do so? All right. According to the first sentence, the mu is 90%, right? So mu naught is equals to 90. So since we do not use decimal in any one of this, right? So let's keep everything in integer. Do not use decimal. So 90%, just use 90. And then the standard deviation from past study is 10%. So sigma is equals to 10. So sigma is given. So the entire problem is a Z procedure problem. And then you also know that alpha equals to 1%. And then since you have 10 data, and then n is equals to 10. So for the x bar, you do have to use your calculator to get it yourself. So that is the given. What about the h naught and ha? Let's do that in another color. So h naught, so what is h naught? H naught is the first sentence. The mean is exactly 90%. So mu is equals to 90. And then ha, you want to show that there is an improvement. So improvement means you have to do better than 90. So mu is greater than 90. Greater than 90% means people are doing better. So that means an improvement. All right, so that is h naught and ha. And then what is next? The next thing that you will have to do is you have to calculate the z, right? The test statistic and p-value. So z is equals to x bar minus mu divided by sigma over square root of n. So that equals to a number. And then you also have p-value. All right. First, this is a data problem. Let's enter the data. So where do you go to enter the data? You go to stat. And then you go to edit. The first one, number one, edit. So edit, you might still have some old data from the previous lecture. So in my calculator, I have some data in L2. So how do you get rid of those data? So you move the cursor. Do you see that? Moving up and down, you move all the way to the top on L2, and then you hit clear, and then you hit enter. So now L2 is clear. And then let's put data in L1. So we enter 92, and then comma 98, 94, 96, 93, 90, 87, 80, 72, and 81. All right, let's double check 81, 72, 80, 87, 90, 93, 96, 94, 98, and another 92. Oh, only 192. All right, so the data is ready. And then you can go to second mode to go back to the home screen. And then you go to stat, you go to test, and then you select the z test. This time we have data, so we select the data option. And then the mu naught is equals to 90. So you clear the old number and then enter 90. Sigma is equals to 10. And then we put the data in L1. So we click second one for L1, second one. And then the frequency, ignore that. Keep that in 1. You don't need to touch that at all. And then my HA is greater than. So this sign is very important. Greater than. That sign is for HA. The calculator needs to know that because the sign determines the p-value. Left side, right side, or two side. And then once everything is ready, you can calculate. So you calculate, you can see that they gave you the x bar by 88.3. Okay, so let's write that down as well. So the x bar is 88.3. What is the z equals to? So you plug in all the numbers to the formula. The z is equals to negative 0.53 and then 8. I will keep 3 decimal places, 3 numbers on the right-hand side of the decimal point. The p-value, 4 numbers on the right-hand side of the decimal point. So that is 0.70, 46, right? And then the p-value is greater than alpha. Okay, how about the graphical representation? For the graphical representation, you can draw that. You can ask the calculator to do it for you. So just simply go back to stat, z-test. So instead of selecting the calculate option, you select the draw option, and then you will see the graph. And then I never use this because it is faster to just do the graph yourself. So this is bell curve, and then we have 0 right in the middle, so 0 right in the middle, and then we have negative 0.538, and then what is the p-value? The p-value is this, so all the purple area, that is the p-value. The p-value is equal to 0.7046. All right. How about the 1%? Where is the 1% rejection region? So the 1%, let me do that in red. So the 1%, the alpha is area, right? So the 1% is right over here. So this is 1%. Right over here. So this is the cut for the z, and then the 1% is right here, 0.01. So since this is outside the rejection region, then we fail to reject the null hypothesis. If you compare the p-value to the alpha, what if you compare the z? So this is a purple z, the test statistic. So test statistic. And then the p-value, how do you calculate the red z? So to calculate the red z, that is equals to inverse norm. And then you input the 0.01 and then 0 and 1. So what is that equal to? So you go to second vars, right? So second vars, and then you do inverse norm 0.01, and then mean is 0, standard deviation is 1. You have to take the past because this is a greater than. So that is 2.326. So 2.326. So since that is greater than the purple z, so if you compare the z to make a decision, the red z is greater than the purple z. So that means you have to fail to reject the null hypothesis. All right. So back to the conclusion. So since p-value is greater than alpha, so we fail to reject h naught. To reject h naught. So that means there is no evidence to prove HA is true. So no evidence to prove HA is true. What does that mean? So that means no evidence to prove that there is an improvement. So no evidence to show the improvement exists. Okay, so no evidence to show that the improvement exists. This language everybody understand. You always have to put this in the context of the problem, because fail to reject H naught for people who never took stats in their life, they don't know what H naught is. So now we already have a conclusion, and then the next thing that I would like you to do is I would like you to use a confidence interval to support your answer. So let's do confidence interval. You can go to second mode to quick, and then for confidence interval you go to stat test. This time you are running a z interval, stat test, and then you do a z interval. And then for the data option, so data option, I have a sigma equals to 10, and then the list is L1. That one, the frequency, keep that in 1, and then this is 1%, right? Okay, I'm going to draw a line right here. I'm going to write this down. So you have 1% alpha. So you have 1% alpha. So that means you are doing a 99% confidence interval. What is the formula for the 99% confidence interval? The formula is you have x bar plus or minus z half alpha, and then sigma divided by square root of n. You don't need to do the plug-in, just show the answer. So let's click calculate. Before we do that, make sure the C level is 0.99. Okay, 99%. And then you calculate. So you calculate the confidence interval is 80 to 96, right? Let's just round this to the nearest integer. So this is 80 and this is a 96. So what does that mean? What does that mean? Explain. These two numbers for me. Explain. So that means we are 99% confident that the average exam score in percentage falls between 86, 80, and 96%. So this is the truth. The truth is mu. We are trying to say that I have 99% confidence that this mu is between 80 and 96, but this is only an estimation. We will never be able to find out what mu equals to exactly. This is only an explanation. How do you use this number to support yourself? I'm trying to support the conclusion. You fail to reach H naught, right? Can you support that? So here is how. First, you recall the H naught. So H naught is mu equals to 90. Is 90 inside or outside the confidence interval? The confidence interval contains the truth, and you propose 90, and 90 is inside the confidence interval, right? So it's inside the confidence interval. That means 90, the statement you wrote in orange, can be the truth. So therefore, you fail to reject. H naught. Oh, what if you have to draw a graph for the confidence interval? So you simply draw a bell curve, and then you have the X bar right in the middle. So this is X bar right in the middle. What is the X bar? The X bar is 88.3. You can see that on the calculator, and then you have a lower limit, you have an upper limit, and then this is 99%, and then the remaining pieces, they add up to 1%. And then you have the lower limit, you have 80, the upper limit, you have a 96. So that is how you draw a graph for the confidence interval. So that's all for the analysis. Here is one question that is pretty hard. I don't usually ask that on my test, but it is good to know. The question is, explain what the p-value means for this problem. So what the p-value means for this problem. So first of all, let's repeat the definition of p-value in the first 3 lines. P-value is the probability if H naught is true, the test statistics from another random sample will be as extreme or more extreme as specified in HA than the test statistics observed from the given sample. So in this problem, there is a random sample, 10 students, right? Everybody got a score. So that is a random sample, 10 students. You can calculate the X bar, you can calculate the sample standard deviation, so on and so forth. What the p-value means, I can grab another random sample. So that means I can go into the record, grab another 10 students randomly, and then the results from the second random sample will be as extreme or more extreme than the one provided in this problem. Again, I can reach to the population, grab another 10 students. The results of those 10 of the second random sample will be extreme or more extreme than the one provided in this problem. So that's what the p-value means. Okay, so in order to put this problem, like plug in the context into the definition, you have to recall the H naught and HA. So the H naught is you have a P equals to 90. Actually, I should not use P. That should be mu equals to 90. The P, I mean for percentage, but it is not right. It should be mu equals to 90. So let me fix that. And then the HA is mu greater than 90. And then this is how you do it. So you start off with if H naught is true. You always have to start with this. If the null hypothesis is true, and then you mention the p-value, there is a chance equal to the p-value, and then you take that straight from the result, 0.7046, that the average final exam score in percentage is greater than, why do I take the greater than? The greater than is assigned in HA, so you take that straight from HA, or equal to. Why do I need to pick the equal to as well? Because if H naught is true, so that's why you have to add the equal to the greater than. Then together, that becomes greater than or equal to 90%. No, I crossed that out. 90% is not right. Most people will just write 90%, but it is not right. It should be 88.3% because that is your X bar. And then this is a right-sided test. So go back to my picture. Do you see that? The purple one, right-sided test. I have area on the right hand side, right? So that means I grab another 10 students randomly. That will be my second random sample. The X bar might be far off to the right side, might be way more extreme than the one you obtain, the 88.3 from the given 10 scores. And then the easiest way to do this is you plug in the p-value, right? And the alternative hypothesis to the definition. And then you change the mu naught to x bar. And when you pick up the sign, don't forget that you have to pick up the sign for the HA and the H naught because you assume that H naught is true. So that's how you explain the p-value for this problem. And then before I end the video, I want to show you more screenshots. So this screenshot is what you're supposed to have on your calculator. So the first one is you go to stat edit, right? So you go to stat and then you go to edit and then you enter the data to L1. And then you go to stat and then you go to test. You select the Z test, you input the data, select the data option, and then don't forget that this inequality symbol is for HA. And then there are two options. When you click calculate, you see the Z and the p-value. If you click draw, you get this picture. And then for the confidence interval, you go to stat test. This time you select the Z interval, you select the data option, and then you don't need to change any of the info except the C level. So the C level is 99%. Once you hit calculate, you get the confidence interval. This is what you're supposed to see on the TI-84. And then for the picture, the calculator is not going to do it for you. So we have X bar right in the middle. So that is 88.3. And then we have the upper limit 96.445 and the lower limit 80.155. So that is a graph for the p-value. So we have 99% in the middle. So this is half of 1% on the left and half of 1% on the right. All right, so that is the end of this video. If you think my instruction is clear and helpful, give me a like, share the video for me, subscribe to my channel if you are new to my channel. See you all in the next one. Signing off for now.